Okay, this one, picoCTF has this one. It's not easy to find this one in a very step-by-step way. A lot of people are shoving these things into programs and running the program, and there's your output. So what I decided to do was go ahead and go step by step, line by line. It falls under the hard category for reverse engineering on picoCTF, but it's actually not particularly hard. It's just a little tricky. And so the key to this one is actually going very slow and being able to get past things that don't make sense. And so we'll go ahead and get started. Uh, this one is a function with parameters. And so this is going to go into the EBP plus whatevers. All local variables, those things will go in the EBP minus stuff as you're going through the function. Before you enter into the function, this is where the parameters start coming in. Clicking on source downloads the binary. This is the binary right here. And so first thing that I'm going to do is I'm going to replace this with the parameter functions like that. And then what I'm going to do is I'm going to make a map of the stack as I go through this. And so EBP, we know that EBP plus 0 is the old EBP that's going to be pushed on there. Don't need that for this stuff. And we know that EBP plus 4 is going to be the return address. I'm not going to worry about that either. I'm just going to start right here at EBP plus 8. And EB plus 8 is going to get the rightmost byte of the first parameter. And so right off the bat, I'm going to say 1/6 there, and then EBP. And instead of showing you by going to the right this way, where we're going to lose a little bit of detail unless I put up column, I'm going to go straight up because we only have 3 parameters and each parameter is only like 4 bytes each. It's not going to take a long time to do this. And so I'm going to do EBP 9, and that goes to the next one, which is going to be 6/4. And then EBP plus alpha. This is where the Charlie 2 is going. And then EBP plus Bravo. That's going to be where the Delta 2 goes. And then here, so we've gone from the rightmost byte and we scanned all the way to the left on building this stack upward like this. Now we're going to go to the second argument, the rightmost byte. So this is going to house F0. And then I'm going to build this stack real quick and won't bore you guys to tears. I'll be right back. Okay, that's all right. And so as you can see, we start with the first parameter going from right to left, building the stack up like this. And this is what our kind of our roadmap looks like as of this point in time. And so here, these first 2 instructions, we have the push EBP and we have the move the stack pointer to the EBP. So these are the prologue to pretty much every program that you're going to see in assembly. And so I'm going to skip over those. And I'm going to start right here at EAX being zored out. And so whenever you see exclusive OR on a register against itself, all ZOR does is say, hey, you're going to get a 0 if you 2 are the same. You're going to get a 1 if you 2 are not the same. And so here we have EAX, which will always be the exact same as EAX. And so when you XOR those 2, you are going to get a 0 every time. It's a way to clean a register, kind of cleanse it out before you start using it. And so we're going to won't ignore it. I'll just make a note. EF is all zeroed out. And so now the next one here. And as I go through line by line, I'm going to take my little roadmap with me. There we go. So here's my roadmap. And the way I always say these things is you're asking me to take 1 byte starting at EVP plus 9. And so here we find EVP plus 9. This is 1 byte, and it's saying to move that 1 byte into the AH register. So I'm going to take this, AH, now equals this right here. And now you may be asking, okay, what is AH? What is that? And so I'm going to show you a good representation for it. All right, there we go. So this is the RAX register, 64-bit, in all of its glory. EAX is just half of an RAX. All it was in the past, we were using 32-bit machines, and then we found a need to go even further, to extend the register. And so that's all this is. This is 32-bit EAX being extended to RAX. And all AX is just half of EAX. And all AH is the higher portion of the AX, and AL is the lower portion of the AX. And so here, what this is saying is the higher gets the 64. And so now, if we were to look at the EAX register right now, it would look something like this. We would have zeroed out everything but, let's see here. So this is what the 32-bit EAX currently looks like according to this program. We have the 64 in the higher, and we have zeroed out everything else. All right, now moving on to the next instruction. Take my map with me. I'm going to leave everything I've done alone so that I can trace that through if I make a mistake. So what this one is saying is it's saying shift left on AX. And so we know what AX looks like. AX looks like 6400. And now it's saying to shift left. Whenever I see a shift left or a shift right or something like that, I want to change this back into bits. And so I'm going to take this 64 hex 00, and this is what the bits look like. And so copy. And so I know that this shift left is saying, hey, you need to shift these bits to the left 16 times, which is equivalent to, I believe, multiplication or division, one of the two. I'm an idiot. I'll have to research exactly which one. But for all intents and purposes right now, just know that this line is zeroing out. You see 0x10. That's not a 10. That's not a 1. That's a hexadecimal 16. So that's why I've been saying, yeah, there we go. That's why I'm saying shift left 16 bits, is because it's telling you take the AX and shift 16. And so essentially zeroing out. And so now once again, we have nothing in, no, there we go. And now on to the next instruction. Here's my map. And so here I'm saying it wants me to take a byte starting at the echo location. So that's this one right here. And it's saying to subtract AL. So AL going to equal. Currently, this right here is AL. That's AL, that 0, 0. So what we're saying is this is 0 minus Charlie Foxtrot. And whatever the result of that is, that will go into AL. Subtract AL, etc., whatever. So if I go to hex, and I say Charlie, nope, sorry. If I say 0 minus Charlie Foxtrot, that gives us bunch of foxtrots with a 31 at the end, 31 in the AL spot. And so AL gets 31. All right. I'll take my map with me. Okay, so now we're taking an entire byte from the location at Foxtrot. That's this echo 6 here. And it's saying to add to AH. And currently, what is AH? AH is currently 0, 0. AL is 31. So right now our register, if we were to point it out, it would be something like this. This is what the register looks like at the moment, the whole AX. And so right now what it's saying is, I want you to add 0 and echo 6 together and put it in that AH spot. So that's going to be echo 6 like that. All right. Take my map. Okay. This is probably the point at which everyone got tricked and everyone gave up and tried to program it. This is a tricky instruction here. What this is saying, instead of give me a byte starting at the 12 spot, the 12 location, I want you to give me an entire word. And a word is just 2 bytes, double word, 4 bytes, etc. So we did AF. So currently, let's write out what AX looks like right now. Right now, AX looks like echo 6, 31. And then we're going to XOR starting here, right here. And so because of Little Endian, it's actually not going to be 44 echo 5. It's actually going to be echo 5, 44. And that was another point that a lot of people got wrong on these, including myself. So now um, I'll do the calculator for it first, and then I'll do it by bit just to show you what it's doing. And so if we have AF, just ignore this. So first I'm going to type it out, echo 6, 3, 1, and then here, XOR, and that's echo 5, 4, 4 equals. Right, so a hexadecimal 375, not a 375, but a 375 in hexadecimal. And so AX would equal right here. And we'll go ahead and check this real quick to make sure that it's the correct answer in pico. And then I'll do the XOR in bit. Okay, perfect. So that's the correct answer. If I were to do this in bits, if I didn't have a calculator with me or something, then all I would do is echo 631, take the text here, copy, paste, take these, hexadecimal, echo 544, like this, go right here. Okay. And everywhere they're the same, they get a 0. And every time that they're different, they get a 1. And then this right here, if I put this into the calculator, here it is, 3 hex is 375. And then down below, it's just a no-op, which is kind of like a landing zone, a safe landing zone. You can just go to no-op and there's nothing that's going to happen to you. And then it's top EBT and then return. And then this solution, um, hex 375 is the answer that Pico was looking for. So this is how you would do this problem set without writing the program. Just going through, line by line and paying attention to how you speak, how you visualize. The big trickster here was you've been dealing with bytes the entire time, and then bam, it suddenly says, I want an entire word with 2 bytes from you, starting at this location. So it's like, hey, go to this location, start at these locations, and then grab this much and do something with it. So that's all I have on this one.